Julia, a dynamic general-purpose programming language capable of high-performance scientific computing with high-level code. It was created in 2012 by a gang of computer scientists who set out to build a language with the speed of C, the dynamism of Ruby, the practicality of Python, that can do statistics like R, and linear algebra like MATLAB out of the box. It's a general-purpose language, but is most well known for its use in numerical analysis, data visualization, and machine learning. It's extremely fast because, unlike most high-level languages, it uses a just-in-time compiler to convert your source code into machine code before running it. And unlike most dynamic languages, it has a flexible parametric type system. That means static typing is optional by default, and types can take parameters, allowing one type to represent many different possibilities. This opens the door to the multiple dispatch pattern, where one function can have multiple methods or implementations based on its input parameters, and the language will determine which method to dispatch at runtime. In fact, even operators like plus are functions that use multiple dispatch to handle a variety of different type combinations. To get started, install Julia, then create a file ending in .jl. Declare a variable by providing a name, then assign a value to it. Names support UTF-8 encoding, like emojis or mathematical symbols. It uses symbols to represent built-in constants like pi, allowing you to write equations more elegantly in your code. Like Perl, it's very good at string parsing and supports multiple expressions on a single line, resulting in terse yet powerful code. Define a function with the function keyword and close it with the end keyword, or shorten it to a single line with the equal sign, or because functions are first-class objects, they can be assigned to a variable or passed to another function anonymously. What's interesting though is that by default a function is untyped, which means it implements one method to handle all inputs. If the function is redefined, but this time with a type for the arguments, another method is added to it. When this function is called at runtime, Julia will look at the type of the arguments and dispatch the corresponding method. In addition, we can pass a type as a parameter, then use keywords like where to perform logic on the type itself. In this case, it will assert that both types are the same. Now, Julia is not an object-oriented language in the classic sense. However, it does support composite types with structs, which contain multiple fields and optional types. Like any good scientific language, it has very well thought out support for arrays, with many built-in functions to initialize and compute values over multidimensional arrays. It supports asynchronous computing with its task model, which can pause and synchronize the execution of code like coroutines in other languages. And finally, when it comes to big data, it can even distribute processing to multiple memory spaces or machines and run natively on a GPU. This has been Julia in 100 seconds. If you want to see more short videos like this, hit the like button and subscribe.